Okay, so when we're working with exponents, we move on to some more things that we talk about rules, right? You might be told that there's a rule that says that anything to the 0th power is 1. And a rule that anything raised to a negative power is 1 over that power positive. But again, rules we often don't memorize, or we don't memorize them correctly, and we tend to get them wrong. So I want to talk about these and give you a better intuition for why these rules are what they are. So let's take a look back at that rule. Anything to the 0th power is 1. Well, why? Why would that be true? The most common wrong answer, can you guess what the most common wrong answer is? That's right. If you guessed this, you got it right. That a to the 0th power is 0. But what you got to remember is that when we're working with exponents, we're working with multiplication. And conversely, division. These are the flip side of the same coin. So we're working with multiplication and division when we're working with exponents. And the only way to get a 0 when we're multiplying is to multiply by 0. So the only way I can have a 0 is if I have whatever that number is times 0. Okay. But that's not what exponents mean. Exponents mean we're multiplying by the same number. So what I want to do is take a look at a pattern, right? So what I mean is that exponents always mean something like a times a. In this case, that's a squared. So the numbers can't be different. So the only way to get a 0 when we're multiplying is that one factor is a 0, the other factor is my number. But that's not the definition of exponent. This is the definition of exponent. So to try to get a little bit of an intuition here, I'm going to take it step by step. So if I have 1a just on the page all by itself, what would its exponent be? Well, 1. I'm not multiplying it by anything. There's just 1a sitting on the page. Now, if I have 2 a's being multiplied together, what is that exponent? Well, that exponent is a squared. There's 2 a's being multiplied together, and we can keep going, right? I probably only have room to write one more. If I have 3 a's being multiplied together, what's the exponent? Well, 3. That's the definition of exponent. But now we got to pull some of our other concepts. So if I think about what's happening in this direction, I'm multiplying by an a to progress up from one exponent to the next. And then to get from this exponent to this exponent, I added another multiplication by a. Well, what if I want to go back down the ladder, right? I started at a cubed and I want to get to a squared. Well, in order to do that, I divide by a. To get rid of one of the exponents, I have to divide by the base. If I divided by a up here, you'd see that pretty readily. Divide by a, cancel the 2 a's. Okay, that leaves me with 2 a's. If I divide by a, cancel pair of a's, I get down here. So divide by A. Well, in order to figure out what's going on over here at the next power down, which would be what? Well, 0. That's my pattern. 3, 2, 1, 0. What's this number? Well, I'm just going to keep dividing. What happens if I take A and divide it by A? What do you get? Well, let's take a look at this. A divided by A. Any number divided by itself is what? 1. So this rule here ultimately comes from the definition of multiplication and division and what's going on. Okay, this is an identity. Any number divided by itself is 1. And when we're working with exponents, we're ultimately working with multiplication and division. So rather than memorizing this rule, understand the concept of this exponential pattern. To go up the exponents, I'm multiplying by that number. And to come back down in exponents, I'm dividing by that number. And anytime I divide a number by itself, it's 1. So in fact, it doesn't matter what the exponent is, or excuse me, it doesn't matter what the base is. The answer will always be 1. So let's take a look at an example. We've got a pattern of multiplying by 2's. So 2 to the first power, 2 to the second power, 2 to the third power. And maybe I'm studying a pattern here. I'm just trying to understand the pattern of multiplying by 2's. 2 to the fourth, etc. Well, 2 to the fourth I happen to know is 16. This is 8. This is 4. This is 2. And the question is, what happens over here at 2 to the 0th power? Well, I'm following my pattern and coming up the exponents, it's a multiply by 2 times 2 times 2 times 2. But coming down the exponents, it's a division. To get from 16 to get to 8, I have to divide by 2. 8 to 4, divide by 2. 4 to 2, divide by 2. Well, I'm just going to keep going. Divide by 2. How much do I have? 2 divided by 2 is 1. So this is why, no matter what number we pick, it doesn't matter, A for anything or X for variable, it's going to be 1 because ultimately I'm always going to end up dividing something by itself. Now, if you need to watch that a few times, try out a couple of these patterns on your own. Feel free. Maybe you can try the pattern with what's 3 to the 0th power. Well, let's try my other numbers and see if we can figure out the pattern. All right, so get it set up. What is 3 to the first power? Well, it's 3 times nothing else. And then 3 times 3 is 9. Okay, 3 times 3 times 3. Well, that's 9 times 3, which is 27. Okay. And then show yourself the work. How do I get from here to here? How do I get from here to here? Well, how do I get from here to here? Coming back down the other way. Okay. And then that pattern still follows when we're coming down to 0. So what should be here and what should be above each of these arrows to prove to yourself why this is what it is? Okay. Now, actually, I use the same argument. I'm this pattern building when I'm working with negative exponents. Okay. These can look intimidating when we first see them. Oftentimes, people will end up subtracting negative exponents. Okay, so again, if we think back to that rule I said at the beginning, it says that any number to a negative power is equal to that number over positive power. But why? Why would this be true? Well, let's go back to our pattern. So if we start up here with a, which means it can be any number, squared. And here we have a to the first power. And then we have a to the 0 power. Well, what's the next a? If we're following this pattern, what's going on with our exponents? What should be right here? 2, 1, I mean, okay, there's a 3 over here, 4, 3, 2, 1, 0. What? What should come here? Well, my pattern looks like I'm taking away an exponent every time, which is what I'm doing because I'm dividing by a to get from here, divide by a, divide by a, divide by a. Okay, but in my exponents, that's reflected as a subtraction. Subtract 1, subtract 1, subtract 1. Okay, so if I'm following the pattern of the exponents now, take away an exponent, take away an exponent, take away an exponent. So we can actually find out what a to the negative first is by following the pattern of the division. Okay, so I'm going to take a squared and divide it by a to get to this step. And you'll see why I'm writing this as a fraction in a second. Right, this is an alternate notation for division, which we prefer to use as we make our way through algebra. Well, to get from here to here, I have to divide by a, whatever a is. But my prior number is a to the first, which is just a divided by a. Okay, that gives me a to the 0th power, which, as we know, is 1. Okay. And then we just keep our pattern going. Okay, this pattern is just going to continue. So I'm going to have a to the 0th, which is just 1, divided by a. So if I rewrite this as 1 over a, explicitly that's a to the first power, then I see this relationship here. Right? And if I go another step down, so that I'm not using a 1, I keep going, I subtract a power. So that subtraction of a power is the equivalent of taking a to the negative 1 power and dividing it by a. Okay, now this notation might be a little unclear. So what I'm going to do is I'm going to change my notation now to, instead of dividing by an exponent, I take the prior term, dividing a negative exponent by a number. I'm going to take this nice notation here, and I'm going to multiply by a fraction. Multiply that by 1 over a. Okay, dividing by a and multiplying by 1 over a are the same thing. So a squared is going to be 1 times 1, which is 1, and a times a, which is a squared. Okay, so this notation was messy. I don't like that. Instead, I'm using this notation for a to the negative first power, and I'm switching how I'm notating my division. Okay, I can go back and do that all the way, and I'll show that in a specific example. But when I'm up here working with these positive exponents, dividing by a is nice. That's fine. I can cancel out the a's. Yay. Okay, but once I get into the negative exponents are messy. I'm already not sure exactly what I'm doing with them, so I'd rather not do that. Instead, I'm going to use this notation where I know that a to the 0th is 1, and I'm dividing it by a. And then to get to the next step, I divide by a again, or equally, I multiply by 1 over a. Gives me 1 over a squared. So let's look at a numeric example. Let's say I'm working with 2's. I'm trying to find out what is 2 to the negative second. Okay, this is my question. What is that? Well, I may not be sure, but I know that 2 to the 0th power is 1. And I know that to get to 2 to the negative first, I have to take away a power. But taking away a power is the equivalent of dividing by the base. So it's the equivalent of taking this prior number and dividing it by 2. 2 to the 0 divided by 2, or 1 divided by 2, which is equal to 1/2. Or conversely, if we're going to use our better notation, we don't like to divide things. Instead, I'm going to say that 2 to the 0th is 1. And to get to the next step down, I take 1, and I don't divide by 2, I'm going to multiply by 1/2. Well, 1 times anything is itself, so 2 to the negative first power is 1/2. Well, what about 2 to the negative 2? Well, I continue my pattern. So take away a power, I have to divide the prior term by 2. 2 to the negative first divided by 2, but we don't like this notation, so I'm going to come down here to the better one. The prior term is 1/2. So to get this, I take 1/2, and instead of dividing by 2, when we divide a fraction, it can get messy. So I'm going to change notations. Instead of dividing by 2, I'm going to take 1/2 times 1/2. So this is my step. This is what I'm doing. I'm dividing by 2. Take the prior term, divide it by 2. But dividing by 2 is the exact same as multiplying by 1/2. Okay, so what is 1/2 times 1/2? Well, that's 1/4. Okay. Or we can say that that's 1 over 2 to the second power, just as this is 2 to the first power. Okay. So even if we don't always remember the rule that anything to the negative power is 1 over that thing to the positive power, we have a pattern of what is going on to get from one number to the next if we're working with exponents. In this case, for a truncated version, we started with 2 to the 0th power, and we know that if I'm going down exponents, that means I'm dividing by that base. Divide by 2, divide by 2. But again, we don't like writing divided by 2 either with the division symbol or stacked like this because this notation with the negatives up here is messy. I already am not sure what negative exponents are. So instead, I am writing this as a fraction. 1 divided by 2 is 1/2. And I'm going to now take that 1/2. Instead of saying divided by 2, I multiply by 1/2 because they're the same operation. And it cleans up my notation and helps me see that 2 to the negative second power is 1/4, but I can always write 1/4 as, or rather I can always write 4 as 2 to the second power. And this would continue. So if I keep going down, 2 cubed, 2 to the negative 3, excuse me, I'm going to get 1 over 2 cubed. Why? Because I'm going to take 1/2, multiply it by 1/2, that's the prior term, and then the new division by 2 to go down a power is dividing by 2 or multiplying by 1/2. Okay, and that's this one right here. That was my new multiplying by half to go down a power. Okay. So this over here, sure you can memorize it, but it's always better to have a deeper understanding, and using this pattern to help you understand will hopefully help. The key right here, again, is this fractional notation. You really need to understand that dividing by a number and multiplying by a fraction, that's that number. Dividing by anything is the same as multiplying by 1 over that thing. Or this order works too.